Greetings, welcome to the lab on Introduction to Regression, Correlation, and Residuals. In this lab, we're going to figure out all the beginning stuff we need to know about how to see a relationship between two numeric variables.
Our first step is going to go back and review real quickly the textbook definition of residual and see if we can breathe a little bit of life into that. So let's start off with taking a look at that. So the textbook's definition of residual says that a residual is the difference between the observed and the expected. The residual of the ith observation, x sub I, y sub I, is the difference of the observed response y sub I and the response we would predict based upon the model of the fit y hat sub I. So the error term, which is our residual, is defined to be this difference between our observed value and our expected value, and we denote that with a little e sub I, okay? All right, the way you get y hat sub I is by plugging x sub I into the model. Let's go ahead and actually draw a picture of this so we can see if we can make this make any sense. So let's come in and let's draw ourselves a set of axes here. So we'll draw ourselves a beautiful vertical axis here, which would represent our response variable. And then we'll draw ourselves a corresponding horizontal axis, which is our explanatory variable. And then we're going to come in here and we're going to plot some points. So we'll have some values that come from our scatter plot. Let's go ahead and represent those here by little stars. Okay, so have this little star here and here and here and here and here and here. And so these points, these data points, what they represent are the ordered pairs x sub I, y sub I that were found by actually collecting our data. And what we can see is, based upon my kind of hacked out drawing here, is that we have a roughly positive linear association. Okay, so once we've got that data point, our next job is going to be to come in and fit a regression line to that. And in the next lab, the lab after this one, we will actually go ahead and see the process by which we actually fit the line. But for now, we'll just go ahead and do it by eye. And let's say that we determined that our best fit regression line is this red line that looks not quite alike but similar to that. Okay, so notice that each of these ordered pairs that are represented by our blue stars here, those are x sub i's, y sub i's. So for example, this ordered pair right here, that ordered pair would be represented by the ordered pair, let's say x sub 1 by y sub 1. In other words, let's just for the moment say that that was our first ordered pair. Now the thing to notice is that there is this vertical distance between our observed ordered pair, the ordered pair we got from data, and the ordered pair that's down here on the regression line, this black dot right here. Well, that black dot right there, that's at x sub 1, y hat sub 1. In other words, our regression line here is being given by the equation y hat is equal to b sub 0 plus b sub 1 x, where b sub 0, that's our old friend the y-intercept, and b sub 1, that's our old friend the slope. Okay, so how do we actually calculate this residual? How do we actually do the calculation to figure out the length of that purple line? In other words, we know that our first residual, based upon our little scenario here, is going to be the length of that purple line right there. Well, the length of that purple line is going to be what? Well, this is the difference between the observed and the expected. In other words, e sub 1 is going to be equal to y sub 1, that's our observed y value, minus our predicted y value, which is y hat sub 1. Now, what's the important thing about residuals? Well, one of the things that we like to do with those is we like to plot the residuals, and then when we take a look at the plot of the residuals, it gives us some nice quick visual information about whether or not we should be using a linear function or a linear equation to describe the relationship between our data. One way of thinking about a residual plot is that we simply took and turned our regression line into the x-axis, and now we want to see, is there a pattern of, say, above, below, above on there, or some sort of strange pattern on our residual plot. Okay? All right, let's go take a look at one of the textbook problems here. In problem 7.2, they ask for us to see some trends, or if are there trends in the residual. So show below are two plots of residuals remaining after fitting a linear model to two different sets of data. Describe important features and determine if a linear model would be appropriate for these data, and explain your reasoning. Okay, so let's go ahead and take a look at the first one here. And they want us to see, is there a pattern here? The fundamental, when you're talking about a residual plot, is that there should be no pattern in the residual plot. So a linear fit, so a linear model fitting to your data, the inference that you make from that is that there is no pattern in the residual plot. If there is a pattern in the residual plot, then that does not bode well for fitting a linear model, okay? So no pattern in the residual plot. That's definitely something that is comp book worthy, something you ought to put in there, okay? All right, and so what do we see in this particular residual plot? Well, if we come over here and this, I'm just going to turn my pen down a little bit, make it a little narrower so we can see that there is this shape that kind of emanates as we go from the left to the right on a residual plot. And they sometimes refer to this as a trumpeting shape. You can kind of think about that you got musical notes coming out here, okay? So it's not good because one of the fundamental tenets of what we'll see in our next lab of linear regression is that the variability remain consistent across all of the data points. And what we can see in this particular residual plot here is that the variability, or that our residuals, are getting larger and larger as the further away we get from the origin. In other words, we move from the left to the right. Notice that over here, the residual on these data points, so just put a few of them in, is much larger than the residuals over here in these data points. So in this case, your response would be, well, no, it's not a good idea to fit a linear model to this, okay? So no linear model. So how would this look if we were typing it up in our homework? In other words, what should we do? Well, I've got the model, or excuse me, the RMD file all started over here in RStudio, okay? And so what we would type in is we would say, let me get myself in the right spot here, say no, there is a pattern in the residual plot, not a good idea to use a linear model. Okay, nice. All right, so hopefully you've got this open while you're watching this lab. This is a good idea so you can actually be typing as you're going along here, all right? Okay, so let's go back and take a look again at our images here, and let's take a look at part B. And if we take a look at part B, we get a residual plot that looks something like this, okay? All right, so as in the last one, let me go ahead and show you that there is a trend in here. In this case, what we're seeing is that there is actually the idea where, if again thinking about the residual plot having kind of as its center the fit that you actually did, whatever the model you fit to it, we see that that's not a line. There's a non-linear fit here. We have this pattern where we are basically below the x-axis, and then for most of the period through here, for most, not all, but for a good chunk of them, we are looking like we're more above the x-axis. And then as we come over here to the right, now it seems to me that we're getting this trend where we're starting to move below again. All right, and so when you see that pattern, in other words, you see a shape in the residual plot, not just like snow on your television set, then that's a bad thing with respect to fitting a linear model to it. So you would not use a linear model here. So no, there is a non-linear pattern in here, is one way of saying it. So non-linear pattern. Okay, so again, we're going to go ahead and type this up in our RStudio file, or RMD, that we've built to do our homework here. So let's say we'd come down and say, let's see, I got quite a few more spaces in here than I need. So we say non-linear pattern in residual plot. Do not use a linear model. So it doesn't mean that there is no relationship or association between the variables. It's just it's not a linear one. Okay, so let's go ahead and we're going to make these videos a little shorter. So we're going to go ahead and call this wrap, and we'll come back relatively quickly and do 7.4.